Hi, so I'm live streaming for Yazz. 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 Hi, so today I'm going to do some coding. So, just to see where I left off yesterday. Where was I yesterday? So, okay, yes. So yesterday. So yesterday I was at the point where I'd make a new DApp in Yazz, and then I'd add the Ethereum builder control, compile it, and then I'd deploy it, and it would get deployed to the Ethereum testnet. You see here it's deploying. Let's get a few more ETH while we're here. This is a 4-sec. This lets you get some Ethereum. Okay. There you see it went up 4.7 ETH. That's not worth $2,000 or whatever. That's just on the test network. Okay, so what we wanted to do was we wanted it that when we did that, it made a smart contract based on that code. So to do that, we had one we hard coded here earlier. So you can see it's a counter, has a count, it has a member variable of 1, which is called count, and you can increment it as well. So that contract is tied to this control, which is a generic control, so it doesn't have any way of interacting with the count. Here's the one we've hard coded earlier. You can see here that it's got increment as a method and count is as well. So this is just hard coded at the moment, which is hard coded. It's hard coded. Where is it? Hard coded. It's hard coded here, this demo contract. So what we want to do So this demo contract, you can see here we've added count and increment. So what we want to do, but the demo contract is actually just a copy of this EVM contract here with a little bit of stuff added. So we really want to take this contract and make a copy of it. Okay, so EVM contract. So where we do that is in the code where we, okay, so let's go back here. Let's just show this working again here. So we're here, we make a new D app, we add the Ethereum control, and then we say compile solidity here. Then we deploy. No, no. How come that exists already? Wait a sec. This shouldn't exist yet. Or maybe we have to restart it, that's why. So we restart Yazz. This is just running locally on my laptop. It's a Node.js program. So we restart it. And you can see here there is no smart contract. We've just got this this generic smart contract control, which only exists in the user interface at the moment. So we select here and we do compile. The solidity is compiled. You can see it's made an ABI, which is the interface from JavaScript to the smart contract. Here's the bytecode. This is the actual smart contract code for the EVM. And we've got some compiler warnings. It doesn't look very good at the moment down here, but that can be cleaned up later. Okay, so what we do is we say deploy, and it takes, on the test network, we say confirm, and it's deploying here. So you can see here it's added this. This is the smart contract. This is the object that connects to the smart contract, which has the increment and count methods on it. Now, in this case, increment and count are actually just they've been hard coded in, and I've literally copied and pasted the code for this contract and copied it here and added these two methods. We can see that if we look at the code. Let's have a look here, methods. So here's where we compile the code. So we compile the code and we get back the compiled code and everything. That's when we press that compile button here. And then when we press deploy, it calls this deploy code. Okay, so here it's deployed some code. And let's see. So it deploys it. So when you see that pop up for MetaMask, that's after we've sent the contract to the Ethereum blockchain, or the test blockchain in this case. I've hard coded the address here for my own MetaMask. We're not ready yet, well, even though it's public now. Oh yeah, that means this won't work. If any of you try this at home, it won't work. So we need This is something we should fix. We can fix this now. So that means when we do deploy here, right, compile, when we get that we need that to work on all your machines as well. So let's see what happens if we take that away first. Now it should not work when we try and deploy. Oh, unexpected identifier. Oh, okay. Okay, so if we put the smart contract control on, compile, deploy. Ah, it fails immediately. Does it tell us why? No, it doesn't. But we know it failed. It doesn't really say much. Okay, anyway, at least we know it failed. So now we need to find a way to get this Ethereum address. Let's maybe, there's some debugger code here. Debugger. So go here, new dapp. Compile. Oh, still got debug code there. Deploy, okay. So here, Web3 dot ETH dot let's see if this works. I'm just trying to find out what our Ethereum address is for MetaMask, because we're using MetaMask here. You can see here we have accounts. See, let's see, we have okay. We've just got one account here, I think. But anyway, that's it. Let me see. Let's see. Let's do here. Console.log. Oh, yeah. This is MB. Maybe it should be get accounts. Wait a sec. look. How do we get? Oh, let's just look it up on the web and see how we do this. It'll probably let me debug it. Web3 JS get accounts. Oh, okay, so for some reason we can't use it in the Chrome debugger, but we can try and do it here. Let's try and make it a property. Default account. No. Let's just see here. Yeah, we can do that. Let's just see if we can use this default account here. See if this works. Wait, so I want to get rid of one of these debugger things. Get rid of that one from compiling. Okay. Let's see now. We're here. New app. Add Ethereum. Compile. Deploy. It says it's null. Oh. Well, maybe we mounted it here. That'd be why. We've got a little debugger here. Make sure. There's the Ethereum control. We're here. Oh, what happened there? Compile. It's almost like there's an error here. Right. I'm going to say it wrong. Oh, it's something weird like. Might be that. I'm not sure. No, what is that? No, we already have the default counter here. So we don't need to do this. hang on, I'm getting a bit lost here. How much have we changed? Oh, let's discard the changes. It's the beauty about source control. Okay, so we have the code here. Let's see. We know we have this is okay. Well, let's try this again. So this should just fail normally first. So this should not work. New, add the code, compile, deploy. Oh, you can see it fails. Okay, good. Well, not the failure it said. What was the error? Oh, no from address. Oh, that was good. Oh, maybe we could do something with that in a bit, couldn't we? Well, let's do that first. Okay, so methods. Compile error. No. So whenever we compile, no, deploy error. Here we can have div v style equals color red. You can say something like and then here when we deploy we can say there's an error here. Okay, let's just try that. See if it works. It doesn't. Whatever. We go here. new app, the smart contract, compile, deploy. Ah, good. No from address specified in either the given options nor the default options. Okay, that's good. So you actually got to make a change, which is good. Show smart deployment error. Okay, so the next thing we want to do is we want to get that default contract address, default account. So you see here, it basically definitely failed though here. We want to say here, put that in there, so you see what it is anyway. Get rid of that one. Get rid of that. Okay, we're just getting rid of the debugger calls so that the code doesn't keep stopping all the time. Because we get breakpoints in here. So we've got a new dapp. Oh, what did we do wrong here? Something. Ah, look at that. We didn't get rid of the double quotes there. Here. Okay. So we have this. Do that. Compile the code. Compile, deploy, and here you can see the default account is the same as that value we had before. Yeah, so now it's actually doing it properly. Deploying, and here we should have the contract address should appear here as well. Yeah. Oh, that's the contract address, and the default account is there as well. Okay, that's good. So that's not hard coded anymore. Let's see if we've got this anywhere else hard coded. Let's get rid of this. Okay, now let's try and run it again. Oh, wait a sec, I think I did something wrong here. This is a totally different call. No, it should be the same. Okay, let's try. over here. So you need the app as a smart contract, compile it, deploy it, pay the gas. Okay, it's deployed. Okay, so you can say we've made that change as well. So we can say remove hard-coded ETH wallet address. Okay. But then the next thing is, we know that we want to create this smart contract here. Whenever we have compiled something, so let's have a look. Let's see. Think about this. Need some heat. One sec. Back in a sec. Okay, let's see. Hope it's not too loud. We'll find out in the recording. But okay. Let's see now. Oh, that is loud. Turn the fan down. Still loud. It feels great though. Okay. I'll turn that off. Let's see. It's in my glasses. Okay, let's see. Okay, so what we want to do now, oh yeah, I wanted to show you what happens when we deploy the code. Okay, so I'll show this again. So when we deploy the code, so when we start off, we have a smart contract, but we have this generic control. Compile Solidity, deploy. So now it's deploying to this Ethereum testnet, and then we should create this this component that we can use to interact with the smart contract, and that should appear here where my mouse is. There. And that smart contract, as you can see, has these extra, it's the same as this, but it has these extra methods on it for the count and for the increment method, which represent these. So we need to take what we need to do is read in this smart contract and start changing things. Okay, but let's just see what happened when we pressed this deploy. Let's see what we do first when we press deploy here. Okay, let's see. When we deploy, what happens is so here's where we deploy. Let's get rid of this hard-coded thing here. So when we deploy, we call copy component. And then we reload we call copy component, which is here. And that basically, that just loads an existing component. But what we want to do, and that reads it from the file system. But what we want to do, that's here. What we actually want to do is we want to make a copy of an existing control. So the control we want to make a copy of is this EVM contract. Let's see how does it do this first? Oh yeah, we read in the text here. Oh yeah. You want to do read EVM contract. And what happens if we read it twice? We read in the EVM contract. We want to replace that text. Let's see what happens if we can do that. Let's see. So let's say read in, then we say source text equals. How do we replace all in JavaScript? JavaScript. Replace all. Here. I'll just do it like that. Okay, let's see if that works. Source text. Replace all. Zuber control. Then we need to load it in. We loaded it in and we read it. Okay, but here we want, okay, let's see here. What is this? Update driver. No. So we want to do like this. Something slightly different, don't we? Zero control. And we can just right. Just have this source text here. These things usually don't work the first time. Totally winging it here. So, let's see if this does. See what that does. If that works, I'll be amazed, but you never know. Stranger things have happened. Stranger things in my code working first time. When it does happen, I normally like, okay, I've missed something. Okay. Let's see. We go here, here. Compile, deploy, confirm. Let's see what happens. It's on the Rigby test network, by the way. Oh, let's see. Oh, let's see something happen. Oh, there, you see, it made a copy, exact copy of the same icon. Before we had some numbers on it. So now let's see. Hey, so it actually did. It did it correctly. So it did make a proper copy. Okay. So let's save this. Right, first. Local test address. Here. Copy main UVM control and load it. Note that we also change the name of the loaded control by changing the UVM source code. So here's where we have to start amending source code dynamically. Could call it better programming, but it's pretty much copy and paste programming, but automatically. Okay, push. Okay. Okay. Now, the thing I've got to think about is I have to think about how this is going to be stored. Because if you're gonna store source code. If you're on a local machine, I mean, okay, eventually when people make code, we want to store it in IPFS. But in this case, there can always be a case where people are just deploying and testing stuff locally. Now the thing is, normally if I restart this, I'm going to want to have a copy of that code somewhere. Otherwise I've lost that code, haven't I? Because when it saves this Yazz file, it references this control, but it doesn't actually store the control source code. So I think I'm gonna have to come up with basically a local cache. And something I'm gonna have to think about is, because look, I created, let's see, I do this, okay? And I make an app, I write some Solidity, I deploy it, and then once I've deployed the Solidity code, here. When I've deployed it, you'll see the component here. Now, I now have something I can add. I haven't added all of the extra functions yet, but I'm going to need to persist this somehow. I want to save it somewhere. I mean, I could just store it in IPFS, but then I'll need somehow to have some sort of reference to it. If it's on a local machine, I could have a directory where it gets stored. I mean, basically, I mean, it's an alternative to not storing on the blockchain. I mean, but you could say, like, for example, everything in this directory is to be loaded up every time I start the system. I guess the thing is, you want to know, I'm just thinking aloud here, but when you have code, you want to, like, how do you know what you want to keep? I mean, this is supposed to be a very stateless system, but I want it to work locally as well with some kind of sane defaults, so you don't have to think about it all the time, so it just feels like it works. And when you're ready to save stuff, you can put it onto the blockchain. I mean, like, you could literally have some sort of button here saying write to blockchain or write to IPFS. The stuff I'm thinking about. It's interesting though, I'm just thinking here though, thinking aloud again, because now we've made the control here, in theory, even though the methods aren't right, in theory I'd like it so that you could then, now you can go in here and you can just compile it again, deploy it, you could make a change, deploy it, and you basically forked, you know, you've just made a copy with some changes of that original code, which is kind of where I want this whole project to go. So it's like evolutionary. So now you should have, it hasn't made a new item. yeah, this is interesting. So you want to store things on blockchain, but you also want to store things locally. And how should you name things so that they're sensible in both cases? And I don't think there's any way we can answer this unless we try different things and see what feels natural. Because you want people to you want people to use this. 1 second. Hey. Hi. Hi. Yeah. Yeah, I can do that, yeah. I'm just finishing my meeting in about 5 minutes, okay? Alright, bye. Okay, so I'm back. Let's see then now. Yeah, I have to think about this, how we store things. Yeah, we want things to be savable on the blockchain, but also savable locally. I mean, maybe when you make a new control, you should have something saying even for a program. I mean, when you hear you've got a download, yeah, and you know, like here you say download.yazz file. That means you're saving it locally, and maybe for the control here, you'd say download control file. Because you can see here, look, now if you do changes, yeah, so here you can see here, oh, okay, look, so we've got here property, so let's do download Yazz file, okay. Now here's the problem. We come out, we come up again, we come in again, and Yazz doesn't know anything about this control file, about this this smart contract component. So here you can see it's just blank. It knows the name of it, but it doesn't know all of that stuff it knew before. So we need a way for it. It could be that within this form, I mean, like if you actually look, I'll show you something here. If you look at the code for this form, alright, edit as text. This is actually, this whole GUI app as text. It's just stored as a text file. You can see here the components it's got. That's the label control. And here's the control for the smart contract. So it knows what it's got. It knows all the properties. Okay. But that's interesting. So if it knows the properties, it could, in theory, allow you. It could, in theory, store this control on IPFS, and then it could have like some sort of IPFS, have some sort of ID here, and if it can't find the control locally, it could load it from IPFS. Ooh. Or it could send it to Yazz, and we could cache it ourselves. But yeah, that would be pretty cool, wouldn't it, if it loaded it all off IPFS? That is very interesting. I mean, at the moment, I'll have to look at what is the concept that, like, how does it, when you load an application, for example, if you're in, just say you're in Yazz and you have some different controls, you have some things here. When you load an app, how does it load these controls? That'd be very interesting. Very, very interesting. I know we've only got a couple of minutes left, but I just wanted to show you today how I code Yazz. So it's just a bit. So I'm hoping to do these every day. I'm going to see what the quality of this is, of course, and if I can do these daily, then eventually I can open them up and do more and more live coding sessions, and hopefully it'll be valuable to me in some ways, because I'm thinking aloud, but also it could be valuable to you if you're interested in how people code, doing Node.js, JavaScript stuff, you know, smart contracts, all that sort of thing. Okay, I don't really have much else to say for today, but I'll wait for the hour to tick on my computer before I go, and I guess because it's Friday today, so I should see you on Monday, I hope. I hope on Monday, yeah. Okay, let's just wait and then before I shut it down. But it's been a good session, so thank you. Okay, thanks a lot. Bye.